Good morning to another present here. Today we are going to see about the computer networks topics in Unit 1 transmission medium. So we have to communicate transmissions through the wire or an wireless medium. Generally we are saying it as an guided and unguided medium. So in this video we are seeing about the guided medium, unguided medium, characteristics and quality determined by the mediums and signal. What are all the guided transmission medium and what are all the unguided transmission medium. So we have to, by using the cable, it is a guided transmission medium. By using the bandwidth and an antenna, that is for an unguided medium. So key concerns for an both unguided and unguided medium is an data rate and then distance has to be an main important design factors. Before we are going to guided transmission medium or unguided transmission medium, we have to considering about the bandwidth of the data transmission. So it will referring the higher data rate data transmissions. So next thing is an transmission impairment, that is called it as an attenuation. So which has to end how the data has to be transmitted without any delays. Next we are seeing about the inference concept, and then number of receivers we will receive in the sender. So it will be having with the multi-point means it will take the more timing. Next thing, first started with the guided transmission medium. So guided transmission medium generally in three types, that is an twisted pair, coaxial cable, and then optical fiber cable. So while we are using a guided transmission medium, frequency range for an transmission medium twisted pair is an 0 to 3.5 kilohertz. In this, typical attenuum is an 0.2 dB, and then same typical delay is an 50 mews, and then repeater spacing is in 2 kilometers. In the same thing, while we are using the twisted pairs 0 to 1 megahertz, in the same thing 0.7 dB, and then 5 us, and then 2 kilometers this also. In while we are using the coaxial cable 0 to 500 megahertz, and then typical attenuation is in 7 database. In the same thing 4 mews, and then repeater spacing is in 1.9 kilometers. Optical fiber cable, it will be having with the 186 to 370 terahertz. In the same thing 0.2 0.5 decibels, and then in a typical delay is in 5 mews. Repeater spacing is in 40 kilometer. So when comparing with these three things, optical fiber is an more optimal. First we have started with the twisted pair. So twisted pair is started with the these kind of mingled with each other. So it will be separately insulated, and then it will be twisted with each other. It will be oftenly it will be bundled with the cable, and then it will be mainly used for an building or an construction surrounded areas. Twisted pair applications we are mainly used in local area applications for mainly to 100 Mbps to 10 Mbps to 100 Mbps. Twisted pair main advantages is an very cheap, and then easy to work, low data rate, and then short data range. So the main characteristics is an analog transmission and also supporting the digital transmission, limited distance, and then limited bandwidth, limited data rate. Here, near and crosstalk in twisted pair cable is an so coupling of the signals from one pair to another pair, and then coupling take place when the transmitting the signal entering the link of couple back to the receiving pair. And then next thing is an shielded and unshielded twisted pair. Unshielded twisted pair is an like an ordinary telephone wire. As a shielded twisted wire is an it will be metal bed, and then it will be very heavy and then very thick. It will be very harder to handling the cables. And then it will in UTP category in twisted pair is an cat 3, cat 4, cat 5, cat 5e, cat 6, and cat 7. Next thing is an coaxial cable. So coaxial cable is an compared with the outer ring and then inner details and then insulation devices. Coaxial cable application is an it will be an aerial to TV, cable to TV, analog to digital, digital to analog conversion, and it will be having with the long distance telephone transmission and then short distance of computer system link, local area network. It will be main useful. Coaxial cable transmission characterization, it will support both the analog and digital transmission. In analog, we will be using the amplifiers, and then in digital, we are using for an repeaters. This is for an optical fiber cable, that is an it will be combined with the core, jacket, and cladding. So these three circle has to be an mingled, and then it will be having a so analog digital transmission, and then angle of transmission and incidence also to be an considered. Optical fiber main benefits is an greater capacity, smaller size, lower attenuation, electromagnetic isolation, greater repeater spacing. Optical fiber main application is in long haul trunks, metropolitan trunks, rural exchange, subscriber loops, LANs, WAN, and MAN. Optical fiber transmission characteristics are an it will be guided for 10 power 14 to 10 power 15 hertz. So it will be supporting with the LED, ILD, and then wavelength division multiplexing. This is an optical fiber transmission mode. First one is an step index multimode, general index multimode, this and then simplex mode. Frequency utilization for an fiber opticalization is an their wavelength is an 820 to 900, and then frequency range is an 366 to 333. Band label is not there, and then fiber type is an multi-mode, then application is an LAN. Wavelength of an next thing frequency utilization is an 1280 to 1350, and then frequency range is an 234 to 2222. It will be an single mode, and it will be an application is in various kinds of applications. And the next thing is in 15282 to 1561. It will be frequency range is in 196 to 192. It will be an single mode, band label is in C, and then it will be used for an WDM. Next thing is an 15612 to 1620 nm wavelength. It will be supportable for the 19585 to 192 frequency range. It will be also in a single mode. This will be a sampling of an our data. It will be how it will be transmitted. In a wireless transmission medium, we are using the microwaves, omnidirectional, and then infrared signals. In a microwave, we are using the 2 gigahertz to 40 gigahertz. The same thing, omnidirectional, we are having with the 30 megahertz to 1 gigahertz. 3 into 10.11 to 2 into 10.14 infrared signals. First thing we are seeing about the antennas. So it will be having an electronic conductor. It is used to radiate the electromagnetic energy to the transmission from source to destinations. So while we are transmitting radio frequency energy from transmitter converted to electromagnetic energy, with that antenna it will be transmitted to the reception. So reception in this electromagnetic energy imping with the antenna and converted to radio frequency electro energy. So same antenna will be used for an both an transmission and an receptions. The next thing is an radiation pattern. So it will be power radiated in all direction. It will be not for same performance in all directions. The direction has to be an different. Our mobile antenna is an radiation based pattern antennas. Parabolic reflective antenna. So it is used to for an terrestrial and satellite microwave. It will be an omnidirectional. So it will resolve the parabolic issues. It will be in signal is concerned at focus where the detector is placed. This is an parabolic reflective antennas. So it will be like a curve. Next thing is an antenna gain. So antenna gain is measured in decibels. So it will be a directionality of the antenna. So if power of the output in particular direction compared with that produced by the astrobatic antenna. So effective area relates to size and shape, not for all area covered. Next thing is an territorial microwave. So territorial microwave is an parabolic dish and then focused on a beam and then light of line of sight. Long haul telecommunication, higher frequencies give the higher data rate. So next thing is an satellite microwave. So satellite is an relay station. It receives on one frequency, amplifies or repeats signal and transmits to another frequency. It will require a geostationary orbit, television, long distance telephone and private business networks. So this is an sample video. With this we have to using the antennas. So and satellite will be in between earth station. It will transmitting the data to the satellite and then it will be transmit to the another side. This will be a multiple data transmitter, multiple receiver and transmitter is there. We have to using this we have to multiple transmitter and receivers. Broadcast radio. This is an omnidirectional type and also it will be mainly used for an FM radio and then UHF and VHF television line of sight serves with the multi-point inferences. Next thing is an infrared. So infrared it will be modulate the infrared light. This is a line of sight. It will be blocked by the walls. TV remote control, IRD port are the main applications of infrared. Next thing is an wireless propagation. So signal travels along three routes. One is an ground wave. Next thing is an sky wave. Another one is an line of sight. So this is a sample. First one is a ground wave propagation, earth to and transmitting the antennas to antenna transmissions. Next thing is an earth wave. So it will be having with the transmitting antennas by using the long spheres. And the next thing is an signal propagation that is by satellite data transmission, LOS propagations. Next thing is an optical and radio horizons. So this will be also in earth based performance by using the optical horizon. So next thing is an multipath inferences. So multipath inferences means there will be a lot of disturbances is there. So microwave by using this we have to transmitting the multipath data. That's all about the transmission medium in computer networks. Thank you.